Hello everyone, you're a network engineer and everything looks fine on the network. But one application owner says there's a problem with the network that's affecting their app. You explain that their application are using the same path and working well. So the issue is likely with their app. In such cases, packet capture is your best friend. In this video, let's see how AI can help us capture traffic and find the problem. Let's go. Here let me talk about the basic setup. So we have 3 leaves, 2 spines. There's a basic underlay configured with configurations mentioned in the screen. And host 1 is connected to leaf 1 and the port Ethernet 1/10.100, VLAN 100. The IP assigned to host 1 is 192.168.100.1 and the IP assigned to host number 3 is 192.168.200.3 and the VLAN is 200. Now if I ping from host 1 to host 3 with a packet less than 1422, it works perfectly fine. But if I increase it beyond 1422, the ping stops working with DF bit enabled. Let me show you what I mean. So right now I am on a 192.168.100.1 host, and which is host number 1, and if I ping 200.3 with 1422, the ping works, right? And if I increase the bit size, the packet size, ping stops working. So -m, this command indicates that fragmentation is not allowed. So if there is something that is not allowed, if some MTU is not allowed in your network, it will simply be dropped and the host will be notified that fragmentation is required. So that's our basic setup. Before I start troubleshooting, let me tell the large language model what the topology is. So I have created a file in the YAML format, and I'll give it reference of the file to understand what the topology is. Okay, so can you create a diagram for the topology using topology.yaml file, and the exact location is, let me look for the exact location. Just give me a second. It is in this folder. Should be something like this. Okay, now after making this topology diagram, LLM will have an idea of what we are working on. Okay, let's give it a minute. Notice that it read the file, it found the file, and it's now reading it. Let's see. It's almost done. Okay, so now this is what the topology looks like. Now large language has an idea what we are working on. So now let me proceed with the troubleshooting exercise. What I'm going to do is I will keep the ping enabled. so that it can capture the exact issue. Okay, so I have mentioned over here what is exactly happening. Take packet capture from device and analyze. Do not make any changes yet. So just analyze it, right? So let me ask LLM to do that. Do not make any changes. Okay, let's see what happens. So now large language know what we are working on, what a topology looks like, and on which interfaces the capture needs to be taken. Okay. So now it's taking a capture. Now this tool, this capture tool, basically takes a TCP dump and places the file in the temporary folder and then pushes that to the local directory. So after the TCP dump completes, it will simply read it from the local directory. So in the first attempt, it used incorrect interface. It should not be taking capture on IRB. It can only happen on physical interface. So this one should be successful. Okay. So I could have mentioned the duration for which the capture should be taken. Since I did not mention, it chose 30 seconds. Okay. Now just to make sure that the ping is running, yes, the ping is running. Okay. Okay, good. Let me capture the uplink to see the traffic flow. I should have mentioned the duration to make it quicker, but bear with me. So it took capture on interface 10. Now it's taking capture interface 1. Just for information, this interface 10 is connected to the host 1, whereas Ethernet 1/1 is connected to the spine. Okay. Now let me look at the capture to understand the M2 issue. Okay. Now it will read the file, the capture that was taken above, and analyze it. The file name is capture_leaf_ Ethernet. Okay. I'll capture the files. Okay. Perfect. The capture shows exactly what's happening. Let me also analyze the EVPN. Okay. Now it will make a now it's going through the documentation. I have placed 2 documents, and it's going through the documentation to see what exactly is happening. It's reading through. It sent a query to one of the documents saying MTU configuration VXLAN underlay, and it got some response, and now it's using that. Okay, evidence from the packet capture. Current MTU is 1500, which is too small. IRB interface 9000 correct for overlay. Okay, so IRB is fine, but the interface MTU is not right. So traffic flow analysis, that IRB is fine, but the VXLAN MTU is not fine. On interface, it's not fine. Okay, can you configure MTU? And it's also specific, it's telling us exactly why it fails beyond 1422. So it's saying that there's a 28 bytes header added to it, 1450, and the 50 VXLAN header, 50 bytes VXLAN header, which makes it 1500. Okay, so now let me request device to make the changes. Can you configure the required MTU, the MTU to resolve this issue? So let's see. So now there is a it's setting the IP MTU on leaf 1 interface 1/10, and then 1/2. Now it's looking into the MTU of leaf 2, sorry. Okay, now let me configure on spine. Let's see what happens. So by the way, in case you're wondering, these are also tools that allows LLM to configure MTU. Right. Now let me verify that. Let's see. So perfect. The MTU is successful. Has been successfully updated. Okay. So if MTU is successfully updated, then the ping should be through by now. So let's go back to the window. Yeah. So the ping is now working. So why is the ping working now? It's because because the MTUs have been changed. So let's see if the MTUs really have been changed. We can do something like Ethernet 1 detail grep MTU. So yeah, so you can see that the MTU has been changed to 9000, and similarly MTU for the other port has also been changed. So MTU has been changed wherever required. Okay, that's it from my side. Thank you.